Now that you understand the idea of the standard error, we'll go through some examples of calculating standard errors by hand. In our first example, we'll calculate the standard error of the sampling distribution that we looked at earlier, which was the means of all possible samples of 2 people that could be selected from that population of 4 people. These are just the 6 sample means that we looked at earlier. Each one was the mean of a combination of 2 people. If we want to calculate the standard error of this sampling distribution, we just need to follow the standard deviation formula because, after all, the standard error really is just a standard deviation. So if we go through the steps and we calculate the standard deviation of these 6 numbers, the answer will be called a standard error. The first step in calculating a standard deviation is calculating the mean of the values. We can get the mean of the values by adding the 6 values and dividing the total by 6. We're dividing by 6 because there are 6 of them. So the mean of this sampling distribution equals 57. And remember, 57 is also the mean of the population because the mean of the population always equals the mean of the sampling distribution. The second step in calculating a standard deviation is to subtract each value by the mean. That's what we'll do right here. So we're just subtracting each value in our sampling distribution by the mean of 57. And this will give us deviations. 55 minus 57 is negative 2. 56 minus 57 is negative 1. These two equal 0. 58 minus 57 is 1, and 59 minus 57 is 2. Each of these deviations is just showing us how far each sample mean falls below or above the population mean. So this sample mean of 55 is 2 below the population mean of 57, so it has a deviation of negative 2. This sample mean of 58 is 1 above the population mean of 57, so it has a deviation of 1. So now we understand what these deviations are. The next step in our formula is to square each of the deviations. You have to multiply each deviation by itself. So remember that we're just following the standard deviation formula, and one of the steps in the standard deviation formula is multiplying each deviation by itself. So that's what we're doing right now. Negative 2 times negative 2 is 4. Negative 1 times negative 1 is 1. These two equal 0. 1 times 1 is 1, and 2 times 2 is 4. Now that we have our square deviation column, we need to do the next step in the standard deviation formula, which is finding the mean of the squared deviations. To do that, we add the squared deviation column, and we divide by the number of squared deviations. And there are 6 of them, so we divide by 6. In an earlier video, I told you that when the data comes from a sample, you divide by n minus 1 instead of n. But that's not what we're doing here because we're actually not finding the standard deviation of a sample. We're finding the standard deviation of a sampling distribution. We're finding the standard deviation of the means of all possible samples. So in this situation, we don't use n minus 1. We only use n minus 1 when we're finding the standard deviation of the people inside of a particular sample. So we divide by 6, and then we get the mean of the squared deviations. Remember, it's called the variance. You don't have to worry about that, but it's called the variance. And the square root of the variance is the standard deviation. So 1.29 is the standard deviation of this sampling distribution. So this sampling distribution over here has a standard error of 1.29. And you might be wondering what that's telling us. Well, what that's telling us is that each of these 6 sample means is on average 1.29 away from the population mean. So so on average, these sample means are 1.29 off target. It's just the average. It's really just the average distance from each sample mean to the population mean that's being estimated. So like I said, on average, each sample mean is 1.29 off target. And it's our standard error. Now what if we wanted to find the standard error of our other sampling distribution, which was the means of all possible samples of 3 people? We would follow the same formula. We would just follow the standard deviation formula. The first step is finding the mean of the values. There's 4 of them, so we add them and divide by 4 to get the mean, which is 57. We subtract each value by the mean to get our deviations. Once we get the deviations, we square them. We multiply each deviation by itself to get squared deviations. Then we find the mean of the squared deviations. We do that by adding the 4 squared deviations and dividing the total by 4. We're dividing by 4 because there's 4 of them. So this is just the mean of the squared deviation column. And if we find the square root of that, we get our standard deviation, which in this case is called the standard error. So this sampling distribution has a standard error of only 0.7. So the standard error did go down when our sample size went up. What this standard error is saying is that on average, these sample means are 0.7 off target from the population mean. Back when we were using a sample size of 2, we noticed that on average, the possible samples were 1.29 off target. But now that we're dealing with a sample size of 3, the possible samples are only 0.7 off target on average. So when the sample size goes up, the standard error goes down, and that just means that the possible samples are more on target, they're more accurate on average. And we're almost at the end of this video. I just wanted to show you a shortcut formula for finding the standard error. And it's this formula right here. I just have to explain what each of these symbols are. This might look complicated, but there's really only 3 symbols in here. This Greek letter, which is sigma, is the standard deviation of the population. It's the standard deviation of the individuals in the population. Little n is the sample size, the number of people in the sample, and capital N is the population size, which is the number of people in the population. So if we want to use this formula to get the standard error, the first step is finding the standard deviation of the population. And then after that, the rest of the steps are pretty straightforward because we just have to know the population size and sample size, and then we can plug them in. So here's our first example. Well, before we go through an example, I'll go through the steps with you. If you want to use the standard error formula, first you have to calculate the standard deviation of the population. And then after that, you can just go ahead and finish using the formula, like I said. So here's our first example. We're actually going to use the standard error formula to find the standard error for all possible samples of 2 people that could be selected from this population of 4 people. In this situation, I'm randomly selecting 2 people out of the 4 people to be my sample, and I want to know what the standard error of the sampling distribution equals. So the first step is just calculating the standard deviation of the 4 people in the population, which is these 4 people right here. So I calculate the standard deviation of their 4 heights, just following the regular standard deviation formula. I divide by 4 because it's an entire population and not a sample. The mean of the squared deviations, or the variance, comes out to 5, and the square root of the variance is the standard deviation. So the individuals in the population have a standard deviation of 2.24. In other words, the population standard deviation is 2.24. That's sigma. And since we know what the population standard deviation is, we can plug in all of the numbers into the standard error formula to get the standard error. So we know that our population size is 4, because I was taking a sample of 2 people from a population of 4. We want to find the standard error for the sample size of 2. In other words, we want to find the standard error for all possible samples of 2 people. So our sample size is 2. So now I plugged in all of these numbers. The population standard deviation, 2.24, which is what we found together. The population size of 4, and the sample size of 2. So on top we have 4 minus 2, and on the bottom we just have the population size of 4 minus 1. That's just a part of the formula. Now we can go through the steps of figuring this out. So first we have to do 4 minus 2, that's 2. Then on the bottom, 4 minus 1, that's 3. Then under the fraction, we divide 2 by 3. 2 divided by 3 is 0.67. Then we just find the square root of 0.67, it's 0.82. Just put this under a square root sign and it comes out to 0.82. Now we should divide this fraction. Divide the numerator by the denominator. 2.24 divided by 1.41 is 1.59. So when you divide this fraction, it comes out to this, 1.59. Now we just have 2 numbers that we have to multiply. 1.59 times 0.82 is 1.3. So that's the standard error. And this formula is a different way of getting the standard error than what we did earlier. The first way we did it was by actually calculating the means of all possible samples and then finding the standard deviation of the sample means. But if we use this other method that I just showed you, we don't actually have to calculate the means of all possible samples. So let me show you how we would have done this using the old method, or the method that we used the first time. So if I wanted to use the old method to find the standard error for all possible samples of 2 people, I would have to actually sort this population out into all possible samples of 2 people. There would be 6 of them. Then I would have to calculate the mean of each possible sample, and I would have 6 sample means. and then I would just calculate the standard deviation of those 6 numbers. That's the old method. But I think this new method that I showed you can be used without having to actually sort out the population into all possible samples.